we're going to be looking at factors affecting capacitance. If we consider a single capacitor which has capacitance C and area of overlap between the parallel plates as A, and the distance between the parallel plates is D. Now if we have two identical capacitors like this in series, where the equivalent capacitor will be this, the total capacitance in series is found by adding the reciprocals, and because they're identical capacitors, they will have an overall capacitance of half of C. The area of overlap between the plates is the same. However, the distance between the plates has doubled. So we have half the capacitance but double the distance. So the relationship between capacitance and distance between the plates is inversely proportional. If we now consider the two identical capacitors connected in parallel, where this represents the equivalent capacitor, to obtain the total capacitance for capacitors in parallel, we add the capacitances, so that is equal to 2C. We see that the area of overlap between the plates has doubled, but the distance between the plates remain the same as D. So we have double the capacitance but double the area. So the relationship between capacitance and area is directly proportional. So we've seen that capacitance is directly proportional to the area, but inversely proportional to the distance between the plates. So if we combine these two relationships, we get this. And to get this into an equation, we need a proportionality constant, and that is equal to the permittivity of the dielectric medium, given the symbol epsilon. Now remember, the dielectric medium is the medium, the insulator between the parallel plates. And so the capacitance is equal to epsilon A divided by D. The permittivity of the dielectric medium can be expressed relative to that of the permittivity of free space, given by the symbol epsilon naught. So the permittivity equals epsilon R, which is the relative permittivity of the dielectric medium, and it has no units. And epsilon naught, permittivity of free space, has a value of 8.85 times 10 to the power of minus 15 farads per meter. And so the relative permittivity of air is 1.003, which means the permittivity of air is 1.003 times the permittivity of free space. And we take the permittivity of air to be approximately equal to the permittivity of free space. And so if we substitute for epsilon into this equation, we get this. If the dielectric medium is free space or air, then the relative permittivity is equal to 1, and so the capacitance will equal epsilon naught A divided by D.